In this video, let's see another type of matrix called as identity matrix or unit matrix. We have already seen in our previous videos few types of matrices. Those are all important, especially the type number 3, 4, 5. That means square matrix, diagonal matrix and scalar matrix. And why are these important? Because these are all related with only minute similarities and differences. Many similarities, minute differences. Now in this video, our focus is identity matrix. So let's see what identity matrix is and let's see some mathematical examples for the same. We'll read the definition first. What is identity matrix? A square matrix. So basically it is again a square matrix. It is related to the previous types that we studied, whose each diagonal entry, that means every leading diagonal entry, is unity. That means it is 1. Since every diagonal entry is unity or 1, hence this type of matrix is also called as what? It is also called as unit matrix. So where I have identity matrix written, I can write the other name as unit matrix also. So what about the diagonal entries? They are all unity or 1. And what about the non-diagonal entries? The non-diagonal entries or the elements are all 0. So does that not mean we have only the combination of 1s and 0s in this? Yes. So we have 0s and 1s, and let's see how this identity matrix would look like. I have a matrix I, and this matrix I is always actually used to denote identity matrix. So wherever you find any identity matrix, you will find it by the name usually I. Right. So I is an identity matrix and it is of the order 2 by 2. So what will this identity matrix be like? Since M and N are equal, it is a square matrix. What about diagonal entry? They are all 1. I know my diagonals are what? They are A11, A22, A33. So diagonals are both 1 in this case. And what about non-diagonal entries? And the non-diagonal elements are 0. So my non-diagonal elements are 0. This is I matrix, unit matrix or identity matrix. Since this matrix was of the order 2, so we will be writing I2. Wherever you find I2, it is basically equal to 1001 as such as this case. What about I3? Now when you know what is I2, you can automatically understand what is I3. I3 means identity matrix or unit matrix of the order 3 by 3. So what will this matrix be like? It will be a matrix with 3 rows and 3 columns. Every diagonal entry should be unity and every non-diagonal should be 0. Diagonal unity means A11 as 1, A22 as 1 and A33 as 1 again. And what about the rest things? The rest things have to be 0. So the rest would be 0. These all would be 0. They would not be 1. This is identity matrix of the order 3. So by knowing these examples, now you automatically can find out what is the mathematical representation. Let's write it. Suppose I have a matrix A and it is basically Aij n by n, y n by n, because it is a square matrix that I need to show. What will be the definition? By the definition we know whenever we talk about a diagonal, whenever we talk about the diagonal, the elements have to be 1. Here we have these diagonals, the elements are basically 1. That means whenever in Aij, I is equal to j, my value is 1. So in Aij, whenever I have I is equal to j, the value of Aii is equal to 1. Why Aii? Because it is basically a square matrix and we are talking about the leading element of the diagonal or the element in the diagonal. What about the other case when I and j are not equal? When I not equal to j, then what happens? Suppose A21 I am talking about, A12 I am talking about, these things. When I and j are not equal, the entries are 0. So the non-diagonal entries are 0. So my Aij is basically equal to 0, and this can be written in this form, and this is the mathematical representation or the mathematical denotation of the identity matrix. So summarizing it, identity matrix is what? It is basically a unit matrix. It is a type of diagonal matrix wherein the entries in the diagonal are all equal and they are equal to 1.